Good morning. Welcome to what I think will be episode number 39 of the ZoomTown experiment. I'm not exactly sure where I'm going to drop this episode in regarding the series in its entirety. But what I want to talk about today is the ZTS. Let me explain to you what it is, and then we'll go into the rest of the story. The Zoomie tracking system is an idea or a concept that I came up with, and its analog would be a GPS, Global Positioning System, which uses a series of satellites to work with devices to track the exact position of objects. In our case, I can't afford satellites to hang above my location and all that, but I can put a camera right over the top of the ZoomTown layout and use a video system to track all the objects. Seems pretty reasonable, right? All around, I think it's a very viable concept. I think it's still feasible, but I did see a major flaw while editing one of the videos that I just put up a few weeks ago. Right now, I think it's July 12th, 13th, 14th, something like that. Middle of July. But anyhow, from that very simple observation, I realized a very serious problem with my concept. We'll get into that a little bit later. But the Zoomie tracking system that I really wanted to come up with was going to be the very last subsystem of the whole ZoomTown experiment. I had hoped to use a Raspberry Pi with vision, OpenCV vision and processing and all that. Just wonderful. I've done similar things before. I have never tracked 16 objects with very precise location data and been able to track it, record it, report it to some other device in real time. Now, what do I mean by real time? Literally within milliseconds. So if it happened now, in a couple of milliseconds, that data is in a Zoomie. Why is that important? All the Zoomies are moving. So if I know the position of something 50 milliseconds ago, that's probably a half inch, 13 millimeters in a whole different location. That's a problem. We're trying to use this data for a number of different purposes, and having very responsive real-time data is the only way this would work. With a GPS system, all the satellites, their clocks are synchronized, so it's reporting data very fast and efficiently, of course, using very powerful systems, which I don't have. But in order to get that very high precision, all the clocks have to be perfectly synchronized. Let's go into a little more detail about how I was going to do it, and then we'll talk about why we got problems with it. To achieve the objective of having a Zoomie tracking system, what I wanted was, in real time, 30 times per second, locate each Zoomie. That seems reasonable for many of the systems today. I doubt it. Raspberry Pi could do it. Maybe the 5 could. I haven't played with one yet. But I was prepared to actually go with NVIDIA Nano or one of those types of devices. That seems to be probably one of the leading, most powerful systems. I think it had 1,024 GPU cores or something ridiculous like that. A year and a half ago or so, when I came up with this concept, I started researching it and only been able to go in and out of it infrequently during all this time. So I haven't gone into enough research yet to have any expert authority, so to speak. But I also wanted it to report its X and Y position, meaning the Zoomie, to the scheduler, which is the central computer running this whole simulation. The scheduler would use this data to help with collision avoidance. For example, The Zoomie could request, it stopped before backing out of a driveway. It could request from the scheduler, is there a Zoomie on the road that I'm about to back into? And it could respond yes or no, so I would know to wait or go forward. Same thing at controlled intersections. And that would be its next function that I list. The scheduler would use this data to help with traffic control. Now the scheduler would automatically send each Zoomie its coordinates X number of times per second. At this point, I haven't got to the testing phases yet, obviously, but I would be able to then ascertain what my frequency was of communicating that data. And I believe originally I wanted it literally at the 30 frames per second or 30 times per second. And that's just kind of an arbitrary number that I pulled out relative to video feed. A lot of video recording we use today, it's a lot of 24 frames a second or 30 frames per second. And that's where that number kind of came from. But anyhow, it would have to send this data, just like the GPS stuff, it's doing things on a regular time interval. The Zoomie could request its position at any point, if it's doing its own tracking and trying to do a comparison of something, or to verify that it got where it's supposed to. And the Zoomie could request the position of any other Zoomies on the same road. And that gets back to that traffic control system. So this overall kind of top-level view of how I wanted the system to work. Very much like the navigation system in your car, or frankly, the better ones that run off your phone. There's one here in the U.S. called, I think it's called Waze, W-A-Z-E. It kind of knows everything. It's remarkably good. Even knows where the cops are hiding, so you don't get speeding tickets. One of my favorites, as you can tell. But nonetheless, it would work in that realm where it's the navigation system is providing positional feedback of not only yourself, of other things in your area. Remember, the Zoomie is blind. It doesn't see a whole lot other than what we've been able to extract out of the sensors so far, and we've gotten pretty good with that at this point. Now, several people have mentioned over time with this whole localization, collision avoidance, and all this stuff, well, Chris, why don't you just put vision system on the Zoomie? Cost. That even if I did a Raspberry Pi Zero with vision at a minimal level, that's going to add a substantial cost to each of the Zoomies. So, and as well as bulk and battery power, and it kind of goes up exponentially, all the demands for that to function. So it's just not feasible for our application. And early on, I knew we would have trouble with localization just using the onboard sensors. I didn't realize they were going to be as bad as they are. Luckily, in the last few weeks, with suggestions from some of you and working around a lot of these issues, we've got a pretty robust system right now. So I think the Zoomie itself is able to help and deal a lot with localization. Okay, so now with that, we've got this vision system that would have been the final thing to really pull all the pieces together to let the Zoomies run around, and we would know very accurately where they are. I believe mathematically, when I worked it out the first time based on the camera resolution, remember the higher resolution of the camera, the more data time it takes to process all the extra data. So I balanced it out to HD video, which would be 1920 by 1080 pixels, X by Y. And then when you work that down to the pixel level, I think we were roughly in the neighborhood of about a millimeter of accuracy there. So that's kind of where that number came from with my desires that I mentioned in earlier videos a few weeks back. Well, all around, we made huge progress doing localization on the Zoomie, but I still wanted this to be that final thing to make it all come together. And in truth, it'd be fun to do. It was a neat idea. I still think it's very feasible. But again, there's just this one problem. Now, to explain that, we're going to have to go over to the test track here, and I'll explain to you there part of the problem with the concept of vision tracking. At Test Track Z, you can see I got a lot of stuff on the table. And what I want you to kind of notice, I've got 4 Zoomies here. These are printed final version bodies with their identification tag on top. The identification tags are 3D printed in 3 colors off the new printer, and they're all very unique characters, of course, in the English alphabet, where a vision system could easily recognize one from the other. And it was very easy using the numbers and letters because I had a good variety to choose from, and we could communicate back and forth in almost any language as to which car was which, or which Zoomie was which. So that's what you see here, and even going forward, whether I use vision or not, I'm still going to use these ID tags on top of each Zoomie so that we can keep track either as we're explaining the video as it's running, or just to identify which one's which, because each one is its own little entity. But where things started to go south was right in this area when we were doing some positional demonstrations on Test Track Z. And what we noticed, or what I noticed, there's a problem. When I conceived the whole idea, I was thinking very two-dimensionally, meaning that everything was at the same Z height going up this way. Okay? I actually did a substantial amount of work with the concept in the 2D world, including a lot of CAD drawings and math and all kinds of fun stuff. Problem is, when things go into the 3D world and you've got a single point camera, which is right there, almost in the center of this table, when it's looking at this, it is looking at an angle coming out. And when it does that, you'll notice that things can be not where you think they are. And things are hiding behind objects. And you probably didn't notice that I had a little helmet guy, a robot, and a couple of my tiny workers who got to get busy working back over on ZoomTown, making all the changes that we've been discussing, but right now they're just goofing off. And I had 3 more tags hiding behind those Zoomies. So camera angles and their perspective can hide or alter what you think you see. How did that come into play for us? Let me get the tags out of the way, at least most of them. Okay, and it all started with, we were watching the Zoomie come along here, and it was stopping somewhere in this area. I think it was at this one. And, you know, I could see from my point of view over here, I could see exactly the front of the Zoomie stopping right on the line. But you folks from the camera saw that this was way over that way relative to where it's really stopping. And the same is true of the ID tag, which is actually what I was going to track with the vision system. It was round, it was easy to identify, I could find it with even the most fundamental tracking systems, and all of a sudden everything kind of left me. It was another one of those amazing failure points where you go, oh man, that Lucinda Williams, everything is wrong again. So that's what I discovered. Now, if I pull the Zoomie back, okay, now kind of get an idea where the camera sees 5 as. 5 is almost, actually it's probably off the table, off the layout completely. So it's that far over. Now, we get that out of the way and we'll put Z in the same position. Now Z would have tracked perfectly. The vision system would have found that perfectly within the layout, dimensionally accurate, and no complex or confusing math to deal with to translate it. That's what I discovered. And you folks probably saw it because I was sitting here going like this. Yep, it's right on the spot, and then I'd look at it and pull it away. It wasn't until editing where I saw, holy cow, the Zoomie looks like it's actually, we'll say if we go this way a little bit, it looks like it's an inch further to the right than it actually is. Ooh, that was almost 2 inches. So that was the problem I discovered. Now, yes, for those of you that have much better knowledge of math, you can easily work out probably the math to take into account the height of this relative to the angle to the camera, and then transition or translate that coordinate down to the table's surface. But that starts to get into a lot more math and complexity for the Zoomie tracking system. And I'm all along trying to do this as economically as I can. If I can do it on a Raspberry Pi 5 at, I think they're $80, and OpenCV, bada bing, I only need one of them, so that ain't so bad. But in all my research up to that point where I was thinking, I don't think a 5's going to handle it. So then I started looking at the NVIDIA Orin Nano, which I think is $500, and I may need additional software on all that. Suddenly, this thing started getting much more expensive, and now I'm okay. I was going to commit to that $500, but at some point, you really got to step back and go, wow. So, where am I at right now with the Zoomie tracking system? In light of what I'm seeing, and even with a very powerful Nano or NVIDIA Orin Nano, I don't know, I suspect the power is there to be able to do what we want. I'm not wanting to go back into playing in C code. I've never enjoyed programming in C. I never want to play with C. It's just not my thing. I would rather spend much more time playing in most other programming languages than C. With C, I know I could get the performance out of it, but it won't be enjoyable. And I'm doing this for enjoyment. So lately, of course, it's all about MicroPython or Python. And I really question if I can get that capability out of the system. Now, doesn't mean it's not possible or anything like that. It's just not something I feel I would want to pursue if I can't do it my way with the programming languages that I'm using today. So with that revelation a couple of weeks ago, everything is wrong. It just keeps ringing through my mind. With that revelation of what I discovered here in video editing, the wind got sucked further out of my sail and I came to a halt. But since then, so much has been learned as to what I could do with that tiny little Pico W, some creative use of the sensors that I never intended to be used in the way they are. Literally, the Hall effect sensors, I'm probably abandoning completely the original intention for them as stop signs or some other type of communication of that type, not a positional thing. The TCRT 5000s, I had no idea I could use that not only for line following, but to very accurately measure the position of where the Zoomie is. That was really, that's next level thinking and next level performance out of that sensor. And so far, I'm really hoping it just holds true all the way through this project, because it's pretty awesome. And then that combined with the Hall effect sensors to be able to preset positions depending on if I enter a road at midpoint, etc. All of a sudden localization becomes far more accurate than I ever dreamed it could be, using probably $2 worth of sensors. So that's pretty remarkable. Then along came the suggestion from Steve a few weeks ago, and I think that video probably played last week, about using this, let me get that, oh here, I could probably show it to that camera. The little camera right here, using that sensor in QR codes, that opened up another whole world of what we could do with this localization in the Zoomies and the PICO W and the ZoomTown experiment. The vision system, the Zoomie tracking system at this point, I think is really backburnered completely. I would much rather focus my time, energy, and creativity trying to do this more so with the PICO W and its little sensors, perhaps just because it's so much more fun. I don't know. So with that, I'm going to wrap this episode up, and I look forward to seeing you in the next episode. Thanks for watching.